So what does that actually mean for your experiment? What does that enable you to do in the end, that high sensitivity? And that's an example, like a little benchmark experiment where we show that we actually, of course, are able to immobilize high levels, high density of your ligand protein on the biosensor. Here it's carbonic anhydrase. It's around 30 kilodaltons in size, and we are immobilizing to a high density over here, getting a high response, of course, for the analyte binding to it. However, if we decrease the density and we go to the middle and to the right-hand side here, we see actually that if we leave the scale as it is, we barely see anything, and the response, of course, gets proportionally smaller here. However, for your experiments and for some biophysical reasons, mainly related to mass transport, you might actually want, and it might be desired for you to go to low densities to, for example, avoid mass transport and diffusion effects for your systems. So if we blow up the axis here, and you can appreciate this is the very same plot as in the middle, just we blew up the axis here, and we see that actually this is data that is very nicely and robustly described by a one-to-one kinetics without even taking into account diffusion limitation, mass transport limitation, whereas on the left-hand side, actually, we use a model that includes mass transport, and it gives us a coefficient also for the diffusion for the system, whereas on the right-hand side, there is no need for that, and we can directly look at the clean one-to-one interaction. That's triplicate data, so it's each concentration is injected in a triplicate, and we're able to resolve full robust kinetics even below 0.5 picograms per square millimeter. And at this point, I'd also like to mention briefly that 1 picograms per square millimeter, which is the unit that our system gives and reads, is directly equivalent to 1 RU that you might be familiar with for SPR system, as for example Biocore. Another example, a bit more applied now together with a partner, one of our customers here, a pharma company, that was interested in looking at a drug target, a ligand that is rather big. So we're having a 110 kilodalton sized protein here, and we're having a reasonably small compound of around 300 daltons. So the ligand to analyte molecular weight ratio is rather big. That means that we will be in this system limited in the response we're getting from the analyte binding to the ligand, because we're only able to immobilize so and so many epitopes, because the ligand, of course, is a really big protein. And still, we wanted to show this, and we immobilized up to almost saturation to a wave chip here. We're getting reasonable responses. We can resolve reliably the kinetics, and we're also here in the system able to go considerably lower with the ligand density and still get reliable and robust kinetic data that can be nicely fit with a simple one-to-one binding model. Another example where we're measuring a small molecule binding, or a kinetics of a small molecule binding to a drug target, is here an even more complex assay, or a more complex system, where we're looking at the GPCR, so a G-protein coupled receptor, these inherently unstable receptors that have to be somehow solubilized in a mixture, or here's just one detergent. So we're having a more complex system, a more complex solution, more complex running buffer. Additionally, here the GPCR is also complex already with an orthosteric compound that is also present in the running buffer and is already in complex with the receptor. And then on top of that, after immobilizing the receptor via its his tag onto a nickel NTA surface, we're able to measure clean and nice kinetics of the allosteric compounds here of interest in an even more complex and less clean system than the systems I showed you before that were measured in pure running buffer. So that's one of the rare examples where we really have shown that we can, in this label-free flow-based system, measure small molecules binding to GPCRs together with our customer leadXpro.